Why did Roger D. Kornberg, United States, win the Nobel Prize for Chemistry?
For his studies of the molecular basis of eukaryotic transcription. In order for DNA to be read for the purpose of producing a protein, there are a couple of key steps that must take place. Kornberg received the prize for his work to elucidate the details surrounding the first key step, transcription. Transcription involves making a copy of the DNA, which is to be transferred outside the nucleus of the cell. Interestingly, Roger Kornberg's father, Arthur Kornberg, also received a Nobel Prize in Physiology or Medicine in 1959 for his work studying how information is transferred from one DNA molecule to another. Who would have thought that his son would go on to win a Nobel Prize for a very related piece of research?
What is a glass transition?
Transition observed in amorphous materials between a hard material and a more liquid or rubber-like state.
What is a superbubble?
A superbubble is a cloud of superheated gas that can be formed when multiple stars that are relatively near each other die out at similar times. This situation can lead to an explosion that spans hundreds of light years in distance. Recall that a light year is the distance that light travels through space in a year. So we are talking about an absolutely huge explosion. The light generated from this explosion is often not in the visible range of the spectrum, so they can't always be seen by the naked eye, not to mention the fact that they are also very, very far away.
What is the earliest historical evidence of the study of chemistry?
Although they didn't call it chemistry, people from ancient civilizations used chemical reactions in many aspects of their lives. Metalworking, including the extraction of pure metals from ores, and then combining metals to make alloys, like bronze, left many artifacts of early man's chemistry experiments. Pottery, including the production and use of various glazes. Fermentation to make beer and wine, and pigments and dyes for cloth and cosmetics are all evidence that man has always been fascinated by the ability to change matter. What is a carbon atom?
Ligand?
A carbene is a molecule that contains a carbon atom with 2 bonds and 2 unpaired valence electrons. This leaves the carbon atom neutral in terms of formal charge, see atoms and molecules, but still typically much more reactive than a typical carbon atom with 4 bonds. Carb-Ns are often found coordinated to metal centers in organometallic complexes. These carb-N ligands are less reactive than a free carb-N species. And actually you might be surprised to learn that organometallic carb-N complexes aren't always prepared from the reactions of free carb-Ns with metal centers. As an organometallic ligand, a carb-N may be either electrophilic or nucleophilic at the carbon atom. See organic chemistry. Carb-N ligands that are electrophilic at carbon are termed Fischer carb-Ns. And those that are nucleophilic at carbon are called Schrock carb-Ns. A third class of particularly unreactive carb-N ligands are termed persistent, or Arduengo, carb-Ns.
What are hard and soft Lewis acids and bases?
The words hard and soft are commonly used to describe two broad classes of Lewis acids and bases. See chemical reactions. Hard acids and bases typically have small atomic, or ionic radii, high oxidation states, high electronegativity, for bases, and are not very polarizable. Soft acids and bases tend to be the opposite in that they have relatively large atomic or ionic radii, low oxidation states, low electronegativity, and are highly polarizable. As it turns out, hard acids tend to react more rapidly and form stronger bonds with hard bases. And the same is true for soft acids paired with soft bases. This pattern is what makes the theory of hard and soft acids and bases useful for predicting and understanding reactivity in inorganic complexes.
What is a pi bond?
A chemical bond in which two lobes of two orbitals on adjacent atoms overlap favorably.
Does eating turkey make you sleepy?
You've probably heard that turkey contains a lot of tryptophan, which makes you sleepy. It's true there is tryptophan in turkey, but not more than is contained in most meats. It's also true that tryptophan is used to make serotonin, a neurotransmitter that makes humans sleepy. The problem with connecting these dots, I'm sleepy after Thanksgiving and tryptophan makes serotonin, which makes me sleepy, is that there are also a bunch of other amino acids in turkey. For amino acids to get into your brain, they need to use transporters to cross the barrier. Tryptophan is competing for a ride on the transporter molecules. With all of those other amino acids you just stuffed in your face.
Brown, United States, and George Wittig, Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their development of the use of boron and phosphorus containing compounds. respectively, into important reagents in organic synthesis. Brown received the prize for his work with boron reagents in organic synthesis, which also led to the development of organoborans as a class of molecules. Wittig worked with phosphorus, developing a reaction through which a carbonyl could be converted to an olefin. This reaction is today known as the Wittig reaction. The work of both Wittig and Brown resulted in the development of useful reagents that find wide application in organic synthesis even today.
What is a vapor pressure?
Partial pressure in the gas phase of a substance in equilibrium with its solid or liquid phase.
What is work?
Work is a name used in physics for processes that transfer energy between objects by the application of a force over a distance. Take throwing a baseball, for example. As your arm moves, your hand applies a force in the direction the baseball is moving. During the time the ball is in your hand and moving forward, you are doing work on the ball. The total amount of work done can be calculated as the product of the force you apply times the distance over which you applied force. Once it leaves your hand, you're no longer applying a force, so you aren't doing work on it anymore.
Does spinach provide a good source of dietary iron?
Spinach has the same dietary content as many other green vegetables. However, spinach additionally contains oxalic acid, which actually prevents iron from being absorbed by the body. Thus it may actually be a worse source of iron than other foods. An interesting anecdote, the iron content of spinach was initially reported to be about 10 times higher than it actually is, all due only to a misplaced decimal point. Spinach does contain plenty of good antioxidants and vitamins, though, so we don't mean to suggest you should stop eating it. It's just that if you heard it was an exceptionally great source of iron, you may have been misled by the original mix-up over how much iron is actually present in this vegetable.
Why did Arthur Harden, United Kingdom, win the Nobel Prize for Chemistry?
And Hans Karl August Simon von Euler-Chelpin, Germany, for their investigations on the fermentation of sugar and fermentative enzymes. Harden and Euler-Chelpin were biochemists who independently investigated fermentation processes. Harden discovered that phosphate was required for alcohol fermentation. Euler-Chelpin studied the means by which living cells produced energy by degrading sugar molecules. and the machinery that cells use to perform these reactions.
Why is graphite so good to write with?
Graphite is an attractive chemical for writing for a few reasons. Graphite, unlike most inks, is not dissolved by water or affected by moisture, but it's easy to erase. Fun fact, we commonly refer to the graphite in pencils as pencil lead, but there's no lead, PB, in there. The Romans did use lead for writing, but the practice didn't make it much farther in history than that. The paint on the outside of pencils did, however, contain lead up through the 1900s.
What are green chemical products?
Green chemical products are products that were designed with the principles of green chemistry in mind so that they will not have harmful effects on human or animal health or on other aspects of the environment. Since the advent of green chemistry, a tremendous number of green products have been developed, ranging from safer household paints to greener cleaning products to new types of plastic products. You may have heard the phrase benign by design, which is often used to describe such products.
Why did Fritz Haber, Germany, win the Nobel Prize for Chemistry?
For the synthesis of ammonia from its elements. Haber was a German chemist, who developed a synthesis of ammonia, NH3, from nitrogen, N2, and hydrogen, H2, along with Karl Bosch, while working at the University of Karlsruhe. Ammonia is critical to many applications, including fertilizers, explosives, and as a feedstock for other chemicals. It is estimated that because of the widespread use of chemical fertilizers, about half of the nitrogen atoms in your body probably pass through the Haber-Bosch process. A significant percentage of our planet's population couldn't exist without this chemical process.
What is energy?
In chemistry, energy serves as the currency for making or breaking chemical bonds and moving molecules, or matter, from one place to another.
What is a molecular orbital?
A mathematical equation describing the position of an electronic in a molecule.
What elements are in your body?
Six elements make up all but 1% of the human body by mass. In decreasing order, they are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. Oxygen and hydrogen are so prevalent because of most of our cells are over 50% water.
How were herbal medicines discovered?
If we had the story of how each and every medicinal herb was discovered, each would likely be an interesting and unique tale. Unfortunately, the use of plants as medicine predates written human history by a few millennia. The earliest written records come from the great ancient civilizations of humankind.
What is the reduction potential of an electrochemical cell?
The reduction potential of a species describes its tendency to accept electrons. Or, in other words, to be reduced. A full electrochemical cell typically involves two separate half reactions, each of which is associated with its own reduction potential. The overall reduction potential for an electrochemical cell is the difference of the reduction potentials for the two half reactions.
What is tribology?
Tribology is a subfield of materials science dedicated to studying the wear of materials. This may include the effects of friction on a material as well as how to better engineer surfaces or lubricate interfaces between surfaces to extend their lifetime.
How can I carry out a chromatography experiment at home?
Chemistry principles encountered in this experiment: extraction, filtration, chromatography. Materials you'll need: rubbing alcohol, 250 ml, small jars with lids, baby food jars work well. Tree or plant leaves, 5 will do. Coffee filters, pen containing hot water, kitchen utensils. The procedure: tear a few leaves up into small pieces, and place the pieces from each leaf into their own small jar. Add a small amount of rubbing alcohol to each, such that the leaves are just covered by the rubbing alcohol. Place the lids on the jars, and then place them in the hot water for 30 minutes. Replacing the water with fresh hot water if it cools. Swirl the alcohol in the jars every 5 to 10 minutes. By the end of 30 minutes, the pigments from the leaves will dissolve, and the alcohol solutions should appear colored. The alcohol serves as a solvent for extracting the pigments in the leaves. Cut long strips of coffee filter paper, remove the tops from the jars, and place one into each jar, with one end in the alcohol, and the other end outside the jar. The pigments will move up the paper different amounts, according to their size. You should be able to see the separation as different colored regions on the paper. Note that this process is a bit different from some of the separations we described. in the modern chemical lab based on polarity or other chemical properties. Unlike chromatography on silica gel, the paper is not strongly polar and thus does not interact as strongly with the polar pigment molecules. Remove the strips of paper and allow them to dry. By comparing the relative distances the compounds traveled, technical term, retention factor, of the different compounds with one another, you should be able to identify whether the different leaves contain the same pigments. You can also try to make your alcohol solutions from other pigments, such as those in inks, foods, or drink. Try to design a hypothesis you can test using this experiment, such as whether or not the leaves of different plants contain the same pigments, or whether different markers or pens contain the same inks.
What is a diastereomer?
A stereoisomer that is not an enantiomer.
One might reasonably ask, why does this distinction even matter?
The reason it matters is that if we went to the moon, for example, the weight of an object would change, because the force of gravity on the moon is different from that on Earth. But the mass would be the same, since the object is made of the same amount of stuff. We just need to make sure everyone is talking about the same thing. We should point out that people commonly use scales to measure either weight or mass. But when we're using them to measure mass, the measurement relies on the fact that the scale has been calibrated based on the strength of gravity on the Earth. So it knows how to figure out the mass of an object from measuring its weight.
How large are molecules?
Molecules span a wide range of sizes. The smallest molecules contain only 2 atoms. And these diatomic molecules have length scales that are approximately the sum of the atomic radii of the constituent atoms. The smallest molecule, HH, has a length of only 0.74 angstroms, 7.4 x 10 to 11 m. Larger molecules can be comparatively quite large. Biologically important molecules, like proteins, often contain thousands of atoms. Polymers, which are highly linked networks of covalently bonded atoms, can be even larger still, sometimes becoming so large they are visible to the naked eye.
Why do some chemical reactions cause a color change?
The colors we see all have to do with what wavelengths of light something absorbs or reflects. For a chemical reaction to cause a change in the color of something, All that has to happen is that the products of the reaction absorb and reflect different wavelengths of light than the reactants do. We'll discuss how light interacts with molecules in more detail in physical and theoretical chemistry.
Can more than one packing arrangement exist for a given chemical molecule?
Yes, this is referred to as polymorphism, and examples are known for most types of crystalline materials, organic and inorganic molecules, polymers, and metals. The way in which molecules pack in the solid state can actually alter some of its properties. Some pharmaceutically active molecules have more than one solid-state structure, or polymorphs. Sometimes certain polymorphs of drugs can be more useful. For example, a specific arrangement could be more soluble, making it more active in the human body. A second polymorph of aspirin, acetylsalicylic acid, was discovered in 2005, but it's only stable at -180 degrees Celsius.
What is an adiabatic?
A process that does not absorb or release energy.
What is a nucleoside?
A biochemical molecule consisting of a nucleobase and a sugar molecule.
What is biodiesel?
Biodiesel is a type of fuel made from vegetable oil and or animal fat which consists of long alkyl esters. See organic chemistry to review functional groups. Biodiesel fuel is commonly distributed for sale as a mixture with petrodiesel, and is labeled with a B factor describing the fraction of biodiesel present. B100 is pure biodiesel, while B20 would represent a mixture of 20% biodiesel with 80% petrodiesel.
What is transmission electron microscopy?
Transmission electron microscopy, TEM, is similar to SEM in that it uses a beam of electrons to study the sample. But in this case the beam of electrons passes directly through the sample to reach the electron detector. TEM images are able to provide higher resolution than that attainable using a light microscope. The first transmission electron microscope with a resolution greater than that attainable with a light microscope was built in 1933, and there have been commercial TEMs available since 1939. So while it may seem like a very advanced technology, TEM is, in fact, quite an old technique.
How are ceramics made?
Ceramics are nonmetallic materials that are made of a mixture of metallic and nonmetallic elements. A ceramic is made by taking an inorganic material, heating it to a high temperature such that the atomic/molecular components can rearrange easily, and then allowing the material to cool to room temperature. The resulting materials are typically strong, hard, brittle, and are poor conductors of heat and electricity.
Why did Willard Frank Libby, United States, win the Nobel Prize for Chemistry?
For his method to use carbon-14 for age determination in archaeology, geology, geophysics, and other branches of science. Libby developed a procedure that uses the relative abundance of carbon isotopes in a sample to determine how old it is. This procedure has been extremely useful to scientists from many fields and has played a major role in establishing the ordering of historical events, including the prehistory of humankind.
What is a liquid-liquid extraction?
Extract ions are techniques used to separate the components of a mixture based on their solubilities in different media. A liquid-liquid extraction specifically uses two immiscible liquids to separate the components of a mixture. Two liquids are placed in the same container and shaken vigorously to allow the dissolved components to equilibrate between the two liquid phases. One liquid can then be drained from the container, and the solvents can then be evaporated to recover the separated components of the mixture.
Why did Francis William Aston, United Kingdom, win the Nobel Prize for Chemistry?
For his discovery, by means of his mass spectrograph, of isotopes in a large number of non-radioactive elements, and for his enunciation of the whole number rule. Following the prize in 1921 for Soddy, the Nobel Committee again recognized the importance of isotopes by selecting Aston for the prize. Aston built the first instrument capable of separating individual isotopes of a given element, which he used to identify over 200 elemental isotopes. This work led him to conclude that all isotopes of all elements have whole number masses. If one defines the major isotope of oxygen to be 16,
How can the presence of blood be detected by forensic experts?
an ultraviolet light source can be used to detect a blood stain that has been cleaned up. It's also possible to use a chemical substance like luminol or phenolphthalein to detect the presence of hemoglobin, revealing its presence even after the visible stain has been washed away.
What is infrared?
Electromagnetic radiation with wavelengths of 750 nanometers to 1 millimeter. Just longer than the visible spectrum, but not as long as microwave radiation.
What's the difference between an H-bomb and an A-bomb?
The hydrogen bomb, H-bomb, is actually significantly more destructive than even an A-bomb. While A-bombs release energy via chain fission reactions, breaking apart heavy nuclei. H-bombs release energy through fusion of light nuclei. This energy comes from an overall increase in stability. Due to the strong force that holds nuclei together as the light nuclei fuse to create heavier ones. To give an idea of the relative powers of these two weapons of mass destruction, consider that the A-bomb dropped on Hiroshima had a force on the order of 10 kilotons. Explosive force equivalent to 10,000 tons of TNT, while a common H-bomb has a force on the order of 10 megatons. Or 1,000 times the explosive force of the A-bomb used at Hiroshima.
Why does the inhalation of helium make voices higher?
After you inhale helium, your voice might sound higher, but the pitch or frequency of the sound waves is exactly the same. Your vocal cords vibrate at the same frequency because your body doesn't adjust for the presence of a less dense gas in your throat. What does change is the speed of sound in helium versus air, because helium has a lower molecular weight than air, the speed of sound is higher. You've probably heard this is because helium is less dense. That's not technically correct, but let's not go there.
What is saponification?
Technically the hydrolysis of triglycerides, i.e., triesters, with sodium hydroxide, more generally refers to hydrolysis of any ester.
Why can't lactose-intolerant people eat dairy?
Most every dairy product contains lactose, which is a type of sugar. Specifically, lactose is a disaccharide made up of one galactose molecule and one glucose molecule. Lactase is an enzyme that breaks the bond that joins the galactose sugar to the glucose sugar to form this double sugar. Lactose-intolerant people lack the enzyme lactase, so they can't metabolize this particular molecule. All mammals can digest lactose when they are first born, but it is very rare for adult mammals to continue to be able to absorb the sugars found in dairy products. Recent studies have suggested that humans only obtain this ability around the same time they began domesticating animals. This makes it possibly the most recent example of evolution in our species.
How was the theory of phlogiston disproved?
Antoine Lavoisier, an 18th-century French chemist, disproved the theory of phlogiston by showing that combustion required a gas, oxygen, and that gas has weight. Lavoisier did this by burning elements in closed containers. These solids gained mass, but the total weight of the containers did not change. What did change was the pressure inside the vessel. When Lavoisier opened the vessel up, air rushed in, and the total weight of the vessel increased. So Beecher had it backward. Oxygen was being used up by the candle instead of phlogiston being given off by the flame.
How much salt, NaCl, is in the average human body?
The average adult human body contains about 250 g, or roughly half of a pound, of salt.
How are formal charges different?
Formal charges are given for individual atoms within molecules. These are determined by dividing the electrons in every bond equally between the atoms that share them, regardless of the elements involved.
Where do I run into organic chemicals in my life?
The food you eat, the clothes you wear, the gasoline in your car, the plastic bags you may, or may not get at the grocery store. The list could go on forever.
Why is fugu toxic?
Fugu fish is toxic because of a molecule called tetrodotoxin. This molecule binds to the sodium ion channels in nerve cells, shutting down all communication in your nervous system. The toxin is not affected by cooking, so chefs that prepare this dangerous fish have to be highly trained to avoid serving parts that contain tetrodotoxin. The liver, ovaries, and skin can have very high levels of this poison.
What is a band gap?
The band gap for a material is the difference in energy between the valence band and the conduction band. This number tells you how good of a conductor a material is. The smaller the band gap, or the less energy it takes to promote an electron from the filled to the empty orbitals, the better the material can conduct electrons.
Why did John B. Fenn, United States, and Koichi Tanaka, Japan, win the Nobel Prize for Chemistry?
For the development of methods for identification and structure analyses of biological macromolecules. For their development of soft desorption ionization methods for mass spectrometric analyses of biological macromolecules, and Kurt Wuttrich. Switzerland, for the development of methods for identification and structure analyses of biological macromolecules for his development of nuclear magnetic resonance. Spectroscopy for determining the three-dimensional structure of biological macromolecules in solution. In the past, mass spectrometry was limited to the study of relatively small or lightweight molecules. Fenn and Tanaka share half of this prize for their work in extending the technique of mass spectrometry to significantly larger biomolecules. Fenn and Takano independently developed two different methods for obtaining freely hovering protein samples appropriate for mass spectrometric analysis. Wuttrich received the other half of this prize for the use of NMR spectroscopy to determine the three-dimensional structure of biomolecules in solution. This represents a significant advance beyond crystal structure analyses, as the structure of biomolecules may differ in the crystalline and solution phases, with the solution phase structure being more relevant to their true biological function.
How are buffer solutions important in the human body?
One very important buffer solution is human blood. An equilibrium between carbonic acid, H2CO3, and its conjugate base bicarbonate, HCO3. Helps blood to maintain a relatively constant pH of around 7.4. The carbonic acid buffer system is created by carbon dioxide, CO2, dissolved in blood. Carbon dioxide reacts with water, H2O, to form carbonic acid. Since the amount of carbon dioxide in the blood depends on the rate at which you breathe, your blood pH is influenced by your breathing rate. Your body can actually tell when your blood pH gets too high or too low and adjusts your respiratory rate accordingly.
What is a bimolecular reaction?
As you might be able to guess if you've read the previous question, a bimolecular reaction involves two reactant molecules undergoing a chemical reaction. They may form a single product molecule, if they combine, or multiple product molecules.
What is a salt?
An ionic compound that can be thought of to form from the neutralization of an acid or base.
What was the first organic chemical ever synthesized in a lab?
plus urea. In 1828 Friedrich Wöhler was trying to make ammonium cyanate, NH4CNO, but this salt turned out to be unstable. It reacted to form urea, demonstrating for the first time, arguable according to some, that an organic chemical could be made from inorganic starting materials.
What's the difference between baking soda and baking powder?
Baking powder is a mixture of three things: baking soda, an acid, and a filler, usually cornstarch. The acid takes the place of the buttermilk or lemon juice in a recipe, see the previous question. To release CO2 from NaHCO3. The starch is in the mix to keep the two components from reacting before it gets into your cookies and to keep everything dry.
Why did Peter Agar, United States, win the Nobel Prize for Chemistry?
For discoveries concerning channels in cell membranes, for the discovery of water channels, and Roderick MacKinnon. United States. For discoveries concerning channels in cell membranes, for structural and mechanistic studies of ion channels. Agar received half of this prize for isolating a membrane protein that serves as a water channel in cells. For roughly 200 years it had been postulated that cells contained channels capable of moving water in and out of cells. But Agar was the first to finally discover a concrete example of a water channel. MacKinnon received the other half of this prize for his work on ion channels, and in particular for his characterization of the spatial structure of a potassium channel. For the first time, this allowed chemists to see how potassium ions flowed in and out of cells.
How do bees make honey?
The first step is searching out a flower to pick up some nectar. Nectar is a mixture of sugar and water. Specifically, the sugar in nectar used to make honey is sucrose, a disaccharide, see biochemistry. A honeybee produces enzymes in its body that can break down the sucrose into monosaccharides, fructose, and glucose, as well as gluconic acid. These sugars are the primary constituents of honey. Most of the water evaporates, which is what makes honey so viscous and sticky.
What is a chemical reaction?
A chemical reaction is any process that involves the transformation of one or more molecules into one or more molecules. Most of the time the reactant, S, and product, S, will be different molecules. A chemical reaction almost always involves the breaking and or formation of new chemical bonds.
What is chromatography?
Chromatography describes a series of techniques used for separating the components of a mixture of chemicals. The most common type of chromatography is column chromatography. This involves dissolving the mixture to be separated into a solution and flowing it over a column of stationary material that interacts to a different extent with each component of the mixture. As the liquid flows over the stationary phase, the components that interact most strongly will be held behind longer, while those that interact weakly will be eluded. From the column first, the liquid is collected into a series of small vials or test tubes, which will, hopefully, each only contain one component of the mixture. The solvent can then be evaporated from each vial to recover the individual components of the mixture. A wide variety of chromatographic techniques exist, and each generally follows the same basic principles as the column chromatography described here.
What is substituent?
An atom or group of atoms occupying a designated position in a molecule.
How can I observe the effects of electrostatic forces using household objects?
Chemistry principles encountered in this experiment: electric charge, electrostatic forces, materials you'll need: nylon hair comb, or a latex balloon, a water faucet. The procedure: comb your hair with a nylon comb. If you don't have a comb, you can also rub your head with an inflated latex balloon instead. As you rub the comb or balloon to your head, it builds up an electric charge on the object due to the movement of electrons between the object and your head. Go to the faucet and turn it on so that a narrow stream of water flows out. Try to make the stream as thin as possible, while still maintaining a steady, smooth flow of water. With the water running, move the comb or balloon close to the stream of water. But be careful not to actually let the comb or balloon touch the water. As it gets close, the stream of water should be deflected toward the comb or balloon. This is because the charge in the object, comb or balloon, induces an opposite charge in the nearby water, and the object and water then experience an attractive electrostatic interaction. Opposites attract. You can experiment with how the amount of deflection varies with the size of the stream of water from the faucet. You can also compare the ability of various objects, different combs, balloons, or different objects altogether, or vary the amount of time you rub the object in your hair.
How are centrifuges used for nuclear power?
Centrifuges are used to enrich the uranium that is used in nuclear power plants. The two main isotopes of uranium are U-235 and U-238. with U-235 being the isotope used to generate nuclear power via fission processes. Unfortunately, over 99% of naturally occurring uranium is U-238. So a lot of effort has to go into enriching the fraction of U-235 present in a sample. Centrifuges are often used to isotopically enrich a sample of uranium in the U-235 isotope. As described in an earlier question, this is accomplished by spinning a centrifuge tube. And in this case the heavier U-238 isotope is weighed down more, allowing a greater fraction of U-235 to be collected, in the gas phase, from the top of the centrifuge. This process can also be facilitated by heating the bottom of the centrifuge tube, which also helps the U-235 to move toward the top of the tube where it is collected. The process is typically repeated many times before the desired fraction of U-235 is reached. Highly enriched uranium often contains 85% uranium-235 though. So clearly people have gotten pretty good at carrying out the isotopic enrichment process.
How do living things store fat?
Fat is stored in a type of tissue called adipose tissue. This is made up of cells called adipocytes that store lipid molecules to be used for longer-term energy storage.
How do the boiling point and melting point of a substance change as a solute/impurity is added?
The addition of a solute typically raises the boiling point and lowers the melting point of a substance. These effects are appropriately named boiling point elevation and melting point depression. Boiling points are raised when a nonvolatile solute, like NaCl, is added to a solution because the solute lowers the vapor pressure of the solution. That is a somewhat circular explanation though. It is important to know that this change in boiling point does not depend on what you add to the liquid. So there are no specific interactions going on here, like forming hydrogen bonds, etc. As long as the solute has lower vapor pressure, remember we said it was nonvolatile. So its vapor pressure is essentially zero, this effect will be present. It is perfectly correct to think about it as just lowering the vapor pressure of the mixture. If you add something with very low vapor pressure, the average vapor pressure of whatever liquid you're adding it to will go down. Melting, or freezing, points are usually lowered when a solute is added to a liquid. The best explanation for this effect is based on entropy, see physical and theoretical chemistry. When a molecule of solvent moves from the liquid to the solid phase, freezes, the amount of liquid solvent, i.e., its volume, is reduced. This means the same amount of solute is in a smaller space, which reduces their entropy, or raises their energy. This raising of energy means that you have to take even more energy out of the system for each molecule that joins the solid phase. Less energy means lower temperature, so adding a solute lowers the freezing point. An alternative way to look at this is that any impurity will disrupt the crystal lattice, raising its energy, relative to the liquid phase. This also contributes to lowering the freezing point as solutes are added.
Why did Walter Kohn, United States, win the Nobel Prize for Chemistry?
For his development of the density functional theory, and John A. Popel, United Kingdom, for his development of computational methods in quantum chemistry. Kohn and Popel represent two of the founding fathers of modern computational chemistry methods. Density functional theory is a method that relies on the function describing the spatial electron density in a molecule to calculate molecular properties. And Kohn was awarded the prize for his substantial contributions to the development of this now widely used approach. Popel also made major strides toward making computational methods reliable and accessible to a large number of chemists. In addition to his more technical achievements, Popel is responsible for developing the Gaussian computational chemistry software that is probably the most widely used computational chemistry tool available today.
How many nuclear power plants are there in the United States?
There are currently 65 nuclear power plants in the U.S. and a total of 104 nuclear reactors. This is because 36 plants have more than one reactor.
How is information encoded in RNA and DNA?
The sequence of nucleotides in DNA can be read only by first separating the DNA double helix, performed by the enzyme helicase. The information is read by RNA polymerase, which then transcribes a corresponding piece of RNA. If the purpose of the RNA is to encode a protein, it can then be read by a structure called a ribosome, which creates proteins according to the specific ordering of the nucleotides in the RNA strand. The ordering of the nucleotides in DNA, and thus the nucleosides in RNA, is extremely important in determining the function of a protein. Nucleotides are read in groups of 3. These groups of 3 are called codons, and each codon tells the ribosome to incorporate a specific amino acid into the peptide/protein it creates. There are also specific codons that tell the ribosome to start or stop creating a peptide. Any mistake in the copying of DNA or RNA can potentially lead to major problems. So it's important that the cellular machinery that carries out these processes is extremely accurate.
What is an atomic radius?
half the distance between nuclei of the same element.
Why do you put iodine on cuts?
The iodine you buy at the drugstore is usually an ethanol solution of elemental iodine, I2. Iodine is a general disinfectant, meaning that it kills all sorts of pathogens, including spores, which are notoriously difficult to kill.
Why does my mom put salt in the water to make it boil faster?
Probably because her mom told her to. There are actually two things that are affected when you add salt to water. First, the boiling point increases. Second, the heat capacity, or how much energy it takes to raise the temperature, decreases. While you might think this would change how fast your pot of water boils, the amount of salt you would have to add to see a significant change is pretty large. The real reason you add salt to water for cooking? Flavor. Salt tastes good.
What was the first molecule detected in space?
Hydrogen was probably the first molecule ever detected in outer space. But you're probably thinking of something larger than that. If you exclude diatomic molecules, like H2, N2, O2, etc. Formaldehyde, H2CO, was the first molecule detected in space.
What is a neutron?
An unchanged arged, subatomic particle found in the nucleus of an atom.
Why did Paul J. Crutzen, the Netherlands, Mario J. Molina, Mexico/United States, and F. Sherwood Rowland, United States, win the Nobel Prize for Chemistry?
For their work in atmospheric chemistry, particularly concerning the formation and decomposition of ozone. Each of these researchers made important contributions toward understanding how atmospheric ozone is depleted through atmospheric reactions. Importantly, each demonstrated ways in which pollution from humans was responsible for depleting the ozone layer. And they did this by learning how atmospheric pollutants caused the breakdown of ozone. This information will hopefully continue to help us protect the ozone layer and the stability of the Earth's climate.
What is a valence shell?
The the highest partially occupied shell of electrons in an atom.
What was the Bhopal disaster?
The Bhopal disaster, also referred to as the Bhopal gas tragedy, was a gas leak in Bhopal, India, that happened in December of 1984. At the Union Carbide plant in Bhopal, methyl isocyanate gas was accidentally released during a manufacturing process. The gas poisoned thousands of people in the surrounding city, most of whom were asleep when the gas leak occurred. The effects of the release of this gas were felt for years to come, with over 500,000 injuries reported in the nearly 3 decades since the incident. Following this accident, criminal and civil suits were filed against the company and several of its highest-ranking employees.
What gives a substance its color?
The color of a substance is the combination of the light that is reflected back at your eye. In other words, you're seeing the light that is not absorbed by the substance. Certain frequencies can be absorbed because of the electronic structure of a substance, while others simply bounce off back into your eye.
What is a tautomer?
Structural isomers that differ only in the position hydrogen atoms.
What is a standard state?
A standard state is a set of reference conditions with respect to which properties can be described/calculated under other conditions. For example, the properties at standard state conditions of a gas may be defined by its properties at 293.15 K and 1 bar of pressure. Knowledge of the properties of a gas under these standard conditions can be used to calculate the properties under other conditions.
How was rayon discovered?
The first artificial silk was probably prepared by a Swiss chemist, Georges Audemars, in 1855. Audemars mixed the pulp of mulberry bark, chosen likely because silkworms eat mulberry leaves, and a rubber gum and used a needle to pull out long fibers of material. This was a rather labor-intensive and difficult process and could not be done in any economic way. Some accounts also claim that Audemars drew fibers of nitrocellulose, the product of mixing nitric acid with cellulose, in addition to being a delicate process. The resulting fibers of nitrocellulose were highly flammable. Hilaire de Chardonnay, a French engineer, was another key player in the history of artificial silk. working with Louis Pasteur in the 1870s. The legend claims that he spilled a bottle of nitrocellulose while working in a photography darkroom. The spilled solution was left to evaporate, and Chardonnay returned later to clean up his mess. Wiping up the residue, he noticed long, thin fibers had formed. Chardonnay received a patent on this material. But again, the flammability kept it from achieving large market adoption. The viscose method mentioned earlier was finally worked out in 1894 by English chemists Charles Frederick Cross, Edward John Bevan, and Clayton Beadle. This method was a commercial success, and the fabric was manufactured first by Courtaulds Fibers in the United Kingdom and then Avchex Fibers in the United States.
Anfinsen, United States, win the Nobel Prize for Chemistry?
For his work on ribonuclease, especially concerning the connection between the amino acid sequence and the biologically active conformation, and Stanford Moore and William H. Stein, both United States, for their contribution to the understanding of the connection between chemical structure and catalytic activity of the active center of the ribonuclease molecule. Together, these three scientists uncovered the structure of the ribonuclease enzyme. And they were able to gain insight into how its structure related to its reactivity. In particular, Moore and Stein were able to correlate the structure of the enzyme's active site to its reactivity. Not only was ribonuclease an important enzyme to study, but their approach paved the way for similar studies to come.
What is a bond strength?
A measure of the energy required to break a chemical bond.
What is a monodentate?
A ligand that coordinates to a central atom via only one atom, compare with chelate.